Here we have a problem where the acceleration changes as the car skids to a stop. We are asked to solve for multiple variables, and to do this we need to first analyze the car's motion. We will look at how the variables affecting the car change as it comes to a stop. Initially we know the car's position is 0 and has a velocity of 75 miles per hour. Since all of our other information is in meters and seconds, we will convert the initial velocity into meters per second. The initial velocity is 33.52 meters per second. Now we want to look at the first part of the trip over the ice. The deceleration of the car is -1 meter per second squared, and we know the car travels 100 meters. We don't know the final velocity or the time it takes to cover the 100 meters. As the car moves over dry cement, it decelerates at a rate of -7 meters per second squared until it comes to rest. We don't know the final position or how long it traveled over the concrete. We also will need to find out the time interval from start of the skid until the car stops moving. Let's first find the speed after the ice. Here is our given information. Notice the variables are labeled with 1s and 2s as subscripts. The 1 refers to the ice portion and the 2s refer to the concrete portion. We need to choose a motion formula that can solve for final velocity without using time. This is our formula. We substitute in our numbers, take the square root, and find the car's velocity after the ice. This will be the initial velocity of the car when it hits the concrete. We are going to solve for the time the car was on the ice. We isolate T1, input our data, and find the time that the car was on the ice. In part B, we want to find the total distance the car traveled. Let's look at our given data. Notice the initial velocity and position for the concrete are the final velocity and the position for the ice. We need to choose a motion formula that can solve for final position without including the time. This is the only formula that does not include time. We rearrange the formula to isolate x2, substitute in our data, and find the total distance covered by the car. We again need to find the time the car was on the concrete. We rearrange to isolate t, input our data, and find the time. Now we want to find the total time to stop the car. We will add together T1 and T2. Here is our formula. We input the times and find the time it took to stop the car.